In this video for the fall final exam review, I'm going to go over numbers 1 through 17. So 1 through 17 is for this video. So here we're starting off with questions where you have to use Desmos in order to solve the problem. So you have no other option. Because like, for example, in number 1, you need to graph this natural log to identify which graph it correlates to. So like here, if you were to graph the natural log in Desmos, so here it is. So now notice how your asymptote is here at x is equal to 3. So notice here, and if you need to, identify other points on the graph. But that's why the answer here is B, our second option. And so now here in number 2, in order to identify which statement, we have to see the graph, right? To see the end behavior, to see where the asymptote is. So you'll need to graph in Desmos, this log here. So when you graph this in Desmos, so here's our graph. Now, of course, you can zoom in, zoom out, but notice that you have this vertical asymptote at x is equal to -4. So that's why here we can cross out C and D because it's a vertical asymptote at -4. So now let's see which of these here. So notice the difference in our first part. So going back to the graph, as x's are approaching infinity, what is the end or what is our graph doing? It's going up to infinity. That's why the answer here is B, because as x approaches infinity, f of x approaches infinity, because the other, as it's approaching the asymptote, it is going down to -infinity. So now in question number 3, you could use Desmos to check and make sure that you have the correct answer. So like, for example, if we're matching which equation, well, I could start off with, well, the y-intercept is at 2. So I know I need a y-intercept of 2. So I'm already down to B or C. But again, you could graph in Desmos to see which matches. I would also make sure that you have the point 1, 3 on the graph here as well. So that's another point to match up. So that's why here, if you look, graphing C, I'm going to zoom in, you can see that C here not only has that y-intercept at 0, 2, but here is also the point 1, 3, just like on their graph here. So that's why the answer here is C. So then in number 4, again, making sure, right, that you graph in Desmos to see which of these matches with our end behavior. However, you'll need to make sure that when you graph something like this in Desmos, keep all of this exponent. See how x plus 4 is all in the exponent? You'll need to type this in parentheses in Desmos, so keep that in mind. And so now here, when you graph this in Desmos, you'll see the graph looking like this. Now again, zoom in, zoom out, but notice you have this horizontal asymptote now, right? As we're approaching here, so -6. So as x's are approaching infinity, right? Because it's still constantly going to the right. You can zoom in slowly but surely, but it's going to the right. So as we're going to the right, as x is approaching infinity, our graph is going up to infinity. So here we are going up and we are constantly going to the right. So here I can cross out C and D. So also I could actually cross out B. So let's check to make sure here that B is our answer, or that A is our answer. As x's are approaching now, is our graph approaching -infinity? Yes, but as the graph is approaching -infinity, our y values are approaching that asymptote at -6. So, oh, I just realized that is a little bit of a typo here. Sorry. So that was supposed to say positive. That's right. So here, that's why the answer is B. So now here in question number 5, if we want to see the graph to identify the domain and range in end behavior. Now notice this is back to our radical function. So this graph, that's like our half graph. And notice the transformation. We're going 3 what direction? To the right. Because remember, this is inside, opposite. So we're going 3 to the right and 5 up. So again, notice here when you graph, here you go. So 3 right, 5 up. So we're starting at the point 3, 5. So domain is x's starting at 3, y values are starting at 5. Notice how we're going to the right. So our x's are greater than, and our graph is also going up. So our y values are also greater than. So the domain is x's are greater than or equal to 3, and y values are greater than or equal to 5. Or you could also remember, right, write this as, because we're including with the bracket 5 up to infinity. Remember, parentheses always with infinity because you can't include it. Then here, as x's are approaching infinity, what is our graph doing? It's going up to infinity. However, as x approaches negative infinity, what is our graph doing? Boom. It's stopping at the y value of 5. So to infinity and stopping at the y value of 5. So now here, number 6, notice we have our cubed root function. So remember, our cubed root function, the domain and range is always all reals. So all reals are negative infinity to infinity. So again, just to check, if you graph it, here it is. So you're constantly going left and right, constantly going up and down. So here the domain and range is all reals. So now the end behavior. As x's are approaching infinity, what is our graph doing? It's going down to negative infinity. And as the graph is going to the left, as we're going to negative infinity, our graph is going up to infinity. So that's why here we have negative infinity, but as x is approaching negative infinity, the graph was going up to infinity. So now in number 7, this is going back to our real world problems like with our quadratics. The tennis ball being dropped from a certain height is represented by this function here. So in order to answer what's the initial height or what's the maximum, how long is the ball in the air, we need to graph this in Desmos. So again, graphing in Desmos, here it is. I can zoom in, zoom out. So notice, where is the starting height of the ball? Right here at 19. So your y-intercept. So the initial height is 19 feet. Then technically, if you notice, that was the maximum, because then it's here and then boom, dropping. That is the vertex, 0, 19. So the maximum height is also 19 feet. That's its height. But now how long is the ball in the air? So again, when does it starts here, right? Because remember, we're not using negative. So when does it reach the ground? Right here. So it's in the air for 1.09 seconds. That's when it hit the ground. Remember, the solutions, the x-intercepts tell you how long it's in the air and how long it hits the ground. And then, sorry, this was a little bit of a here. We already just did that. So number 8, in order to identify which of these statements is true, you could use this and graph in Desmos to see how it looks, then identify which of these statements describes. And we're going to select 3 of them. So like here, for example, here is the graph. Now keep in mind, this situation is talking about lily plants growing in a pond. So can we have a negative amount? No. So we are starting at the y-intercept, which is here at 50. That is the start. Then constantly going up from there. So again, starting at 50 and going up. So there were initially 50 lily plants in the pond. Yes, that is true. So the number of lily plants will always range from 50 to infinity. That is also true. So now, did the population decrease as the number increases? Well, no, because if you recall, see, the graph is going up. So as they're increasing, the lily population is increasing. So E is not a solution. So now notice, we're looking to see when x or t is 2, is this the value? So option 1 is we could find 2 on the graph. So we could locate 2 on the graph, or see how we're dealing with a very large graph? Remember, you can use and turn this into a table. So how do we turn this into a table? Click on the wheel, edit, then notice here's your table. So now notice when x is 2, the y value is 450. But now notice this said 4,050. So B is not our answer because it's at 450. So let's check D. This is after 3 months, the value is 3,350. So here we go. Well, we don't have the value of 3, but you can add it. So when we have 3, we're at 1,350. That point is what's on the graph. But this said 3,350. So that is not it. So now let's check F. So at 6 months, 36,450. So at 6, so let's type in 6. There it is, 36,450. So that's why the answer is also F. So now here in number 9, we're talking about our normal distribution. We have a mean of 400, so here's our mu. Standard deviation of 20, here's our sigma. What percentage received between 460 and 500? So here, now notice we have our empirical rule. So this is when you have 1 standard deviation, 2 standard deviations, and 3 standard deviations. So let's see. So here the mean is 400. So that means standard deviation, 1 above, is 420. Then here we're at 440 and 460. And sorry, I just realized as I'm going through here that this was also a typo. It's fixed, but this was 340 and 460. So here we go. So again, now we're going to go 1 less. So now we're at 380. Then again, subtract 20, 360. Then subtract, now we're at 340. So notice how 340 was 3 below, 460 was 3 above. That's why the answer here is D. So then in question number 10, again, you're focusing on which interval represents 95%. So that's 2 standard deviations. So again, your mean is 34, standard deviation is 2.5. So now here I'm at 36.5, but 2 is now 39. Then here, 2 below. So first we're at 31.5 from subtracting our standard deviation. And then 1 more, we're at 29. That's why the answer here is A. So now number 11, here we're talking about the mean is at 150. So 150 with a standard deviation of 36. So we're looking for at least 100 inches. So here, 1 standard deviation is 186. Now I'm going to stop so we can see where the 100 lies. So 36, we're at 114. 36 now, but we're at 80 or 78. So now notice, was 100 on the curve? No. So this is when we would use technology to set this up, where we have our mean of 150, our standard deviation of 36. Then we would also set up our lower bound and our upper bound. So if we want at least, right, 100, at least, that means 100 is the lowest. So that is the lower bound. Then we would put a million or infinity for the upper bound. So now remember, we have to use Desmos here. So just to show you, this is when you type normal and then distribution. Notice how it stops. So now we open up our parentheses. So now notice here, right? The mean goes first, then the standard deviation. So our mean was 150, standard deviation of 36. So here we're at 150, comma, 36. Now close. See, now here we would usually use that option CDF. We're going to find that cumulative. So click on that. Now notice we can put in our minimum and maximum. So the lower bound was 100. The maximum, we can put 1 million, or we can just keep it at the infinity. So notice here's our probability at 0.92. Or we could say this is the same as 92%. So now here in number 12, this is kind of like a two-parter because we're looking for the z-score, and then we're looking to see what describes the weight at 26 minutes. So let's first go ahead and get the z-score. So remember, z-score is, we're going to take that 26 and always subtract the mean. So what is the mean? 20. Then divide by standard deviation of 4. So that's how you get a positive 1.5. And because it's positive, it's 1.5 standard deviations above because it's positive. So I'm going to go ahead and cross out C and D because it says below. Now again, because this is above, to figure out the percentage, again, we're going to set up that lower bound, upper bound. And because it's above and higher than the mean, that is the upper bound. So again, we're going to use negative a million or negative infinity. So here we go. So again, we're going to get normal distribution. Here you have the mean of 20 with a standard deviation of 4. Close the parentheses because now notice here, right? Get your CDF. Then we had the maximum was 26 because it was above. So notice here, our percentage 0.933. So that's why the answer is A with your percentage. So then in number 13, same thing. We have the mean, we have the standard deviation, but we're looking to figure out which it describes if you had 14 grams. Now notice how 14 is less than 18, right? So when we're talking about looking at the percentages, we're at the lower bound and upper bound. And because it's less than, we are now going to take the lower bound. So again, less than this. So this is your upper bound or your infinity or 1 million. So here we go. So we're going to set this up. I'll go ahead and change it. So this is 18 and 5. Actually, you know what? Here, let's redo it. So we're at normal distribution at 18, 5, right? Because remember, mean standard deviation. Then here, then remember, it was lower the amount. So we're looking at 14. So it is lower than by approximately 80%. That's why the answer here is A. So now question 14. We're looking to see which scenario would be best for an observational study. So observing, not asking a question strictly or dividing into groups and having a control group. So like, for example, A, a group of dog owners register their dogs for a special food diet designed to help with obesity, but there's nothing in terms of the observational. So this is not A. Questioned and monitored. So far, here's our monitor in order to determine the effectiveness of the special food. So far, so good. Randomly separated into 2 groups. So this is an experiment. So the answer is not C. So then 14, a group of dog owners volunteer for their dogs to go through a randomized treatment. Now, some people would go, but they're having their heart rate monitored. But here, they're going through a treatment. So because you have a treatment group, this is technically also an experiment. That's why the answer here is B. This is strictly an observational study, questioned and monitored. So question 15. We're looking to see the two methods that would select the sample at random that would represent the entire Senate. So if you just take 10 senators from the 5 largest states, what happens to the other states? So A is not it. You only take from the people who have served the longest. Well, what about everybody else? Now here we place all 100 senators individual slips of paper placed into a bowl and then select 10 from those 100. So that is one of our answers here. Because again, we're trying to figure out the selecting randomly, but starting with the entire Senate, which you did here. You send letters to all the 100. However, you only talk to or select who replies back the quickest. So that's like a convenience for that self-select. So that's why the two answers are C and E. Again, focusing on the 1 to 100 and randomly select from there. So then 16. This is the relationship between when you have a sample size and a population. Now keep in mind, there is that concept that we've talked about, the sample to sample variability. So again, you could have that relation where it's always going to change and vary from sample to sample. That's why the answer here is B, because again, they're going to vary from sample to sample. Again, that's that idea of the variability. So now in 17, you're looking to see based on the curves here, what's the relation between population A and B? Well, if you think about the number line, right, as you go to the left, your values get smaller. As you go to the right, your values get larger. So I could already tell by looking here, remember, right, the mean always cuts in the middle. So if I were to look at the population A, the mean, versus population B, we'll notice population A, the mean, is smaller or less than, lower than population B. So the mean for population A is lower than population B. That's why we can cross out C and B. Now also notice, remember, standard deviation is about the spread of the data. We'll notice that this spread is much smaller than the population B from this mean. So that's why the answer is A.